science, from industry, and also from the public in general. And the National Center for Charging Infrastructure is known in Germany as the Nationale Leitstelle Ladeinfrastruktur, where I'm working for. Is a special brand of NOW, and we are dealing with the build-up of a charging infrastructure in Germany for passenger cars, but also for trucks and heavy-duty vehicles. So I'm really glad that Andreas Kammel yesterday spoke also about heavy-duty charging and made clear that it is necessary to build up very quickly and with very strong power this network for charging electric trucks. So for this, we have different teams, like a team for planning. Those experts there, they know where to build up charging infrastructure for passenger cars and for trucks. They know about the quantity and also the quality regarding the power of the charge points. We have a team for understanding, so they interpret the utilization rate and the utilization at all of those charge points. And we also have teams which develop and modernize funding programs for charging infrastructure. And also my team, the team implementing, we are dealing with this hardware components, so AC chargers, DC chargers, power electronics, and also the whole process, like how information gets from the car to the grid or to the EVC equipment or in backends and so on. So that's why it's really a pleasure for me to moderate this last session for today, because it's very close to implementing. All three speakers are very close to implementing projects, and I'd like to welcome Marc Mültin. So applause for him, please. So, the mic, I don't know. So thank you. Yeah, Marc Mültin, we know us since, 2017, so quite a long time. You have 13 years experience in e-mobility. You are holding a PhD in computer science. You founded Switch in UK back in 2020. And you are familiar with the whole topic of ISO 15118, so you are a member and trusted advisor at these things. So, I'm glad to hear what you have to say.
Thanks for the warm welcome, Sebastian, and I'm glad to see so many still here on a Friday afternoon. I have the great responsibility to keep you awake after the after-lunch low. And on top of that, I'm talking about standards, not the sexiest topic. So, great responsibility here, but I'll try to keep it interactive. I do have a few sweet treats for those who are going to interact with me during this talk to keep you a little bit incentivized with some sugar. Maybe to start off with a little bit of a story, where I'm coming from, about my background. We had a question on the first day yesterday, how long have people been involved in the whole V2G topic? So my story goes back all the way to my PhD days at the University of the Karlsruhe Institute of Technology. And I was trying to see if I can find some pictures from my activities back then. We actually worked on a research project called Meregio Mobil. Anyone in this room aware of this project or ever heard of this project, I wonder? Stefan, okay. All right. So the idea here was to integrate an electric vehicle into the energy management system of a smart home, and also to simulate a grid with some 4-quadrant device. So we built this not very sexy looking building on our campus, and we had some students living in it, our guinea pigs, but they were living for free, so that's a great incentivization for students. We had a combined heat and power plant, we had smart appliances, 2 little bedrooms, living room, solar roof, and Opel was providing a Opel Meriva, but they put out the combustion engine and put in an electric motor. And my part was to communicate between the car and the charging station using the very early draft of ISO 15118. So back in 2010, when the ISO 15118 became a standardization body, that's when I joined. And yeah, this is an even found a video of this project. So if anyone is interested, the title Elektromobilität 2.0, wenn die Spülmaschine am Elektroauto hängt. Yeah, well, journalists. So basically, I was talking about the project, and eventually in 2014 is when I graduated on the topic, where the title was the electric car as a flexible energy storage device, so to say. So basically, this was my research topic from 2010 to 2014, and basically 10 years later, it's becoming a hype topic. So I'm really excited that we're finally there. Let's see when we see V2G capable cars also for AC charging in the market. The famous is going to be next year. Let's see how many more next years there will be. Good. So, but to the actual content of this presentation. How do we get to a scalable and seamless V2G ecosystem from the EV to the charger to the backend to the vehicle-to-grid aggregator? So there are several actors in this ecosystem, and I'm trying to picture here the kind of communication protocols that are relevant, because we do need standards. We do need to agree on a common language. If the car and the charger and the backend, they all speak broken language, then it's not going to be seamless, for sure. So here is where the treats come into play. Who can tell me, well, that's maybe not a very difficult one, but let's make it a bit more difficult. What's the communication protocol between the vehicle and the charging station that is going to be used for vehicle to grid? I named it already, not that hard. ISO 15118, exactly, good. But there wasn't the hard one. What other communication protocols, and the first one that speaks gets a Mars, do you know that are active, maybe not necessarily for V2G, but in general, between a car and the charging station? Louder? Nope, sorry. Not between the vehicle and the charger, though. Yes, there you go. Ah, sorry, my bad. All right, it's okay. So we have 15118, we have CHAdeMO, we have the Chinese GPT standard, which is only relevant in China. Zhaoji, exactly. Sorry, only one treat for this one. And the IEC 61851, this is the analog signaling mechanism, which is the basic foundation for ISO 15118, which is for the pulse width modulation. Next one is a pretty easy one, so no points for that, sorry. That's OCPP, the Open Charge Point Protocol, 2.1. So 1.6 is the version that's out there in the market. Probably, I don't know, 99% of chargers out there are probably working on OCP 1.6. And then there's 2.0.1, which has been published in 2018 the first time, I think. But now for V2G, there's going to be a new protocol, OCPP 2.1. And I'm going to go into a bit more details on it later. Now, between the utility distribution system operator and the charge point operator, who can also act as an aggregator, what kind of protocols do you think come into play here? And the prize is Twix.
I think there are several options, like the Open Smart Charging Protocol, developed also by the Open Charge Alliance, and the Open ADR, but in practice in the Netherlands, we use APIs or just standard profiles.
Okay, very good. So I hope I don't embarrass myself. I'm sorry. Yes. So he said Open ADR or the Open Smart Charging Protocol. So the Open Smart Charging Protocol, I think, has been developed by the OCA as well, or some group, but it's not really widely used, other than in the Netherlands. So this is what I come across often. OpenADR, the Open Active Demand Response, that's what it stands for. Then we have IEEE 2030.5, which is basically the smart energy profile from mainly used in the US, or a big topic in the US. Also in competition to ISO 15118, especially from the utilities point of view. There's SunSpec Modbus and IEC 61850. I think the IEC 61850 is more a topic in Europe, as far as I know. But here you can see already the problem. We don't have a common language. There are so many different standards out there, and we really need to agree on something. Maybe it doesn't have to be a single one. Maybe we use two, but it just helps reduce the costs and increase interoperability. Right, next one. So between, let's say, the charge point operator and a roaming platform, what kind of protocols do we have here? Anyone? Yeah, who was the first one? You, okay. So far in the back, Jesus, all right. It's gonna be Milky Way. Yes, all right. And another one you may know as well, but it's maybe not as widely known. OICP, that is correct. What did you say? OCPI, right? Yeah, the other one. That's the Mars. Who said it? Okay. Ah, Jesus. Okay, almost. So we have OICP, which is the Open Intercharge Protocol, which is a protocol from Hubject for connecting to their roaming platform. The idea behind the roaming platform is that you can reduce the costs for every charge point operator and every mobility service provider to talk to each other. So it's kind of like a market platform. And then we have also what I have in parentheses here, the IEC standards that are still under development. I'm not too much involved in those IEC 63110, which could be an OCPP replacement, at least that's what they hope for, or the IEC 63119. Personally, I would not bet on these protocols. I personally hope that they will die, because I don't think there's any reason why we would need anything else in OCPP between the charger and the backend, but we will see. Last one, maybe a bit more tricky. For plug and charge to work, right? It's not just about V2G and V1G, it's also about proper charging and seamless charging. There's a public key infrastructure necessary and an ecosystem that is currently provided by Hubject. Who knows the protocol that Hubject is providing to connect charge point operators and mobility service providers and others? It's a tricky one. Thought so. Okay, it is called the Open Plug and Charge Protocol. So as you can clearly see, this industry is not very creative when it comes to naming protocols. And to give you a little help here, I have the legend at the very bottom. So you have the letters O, C, and P in 4 protocols. That's quite a challenge. So what I want to focus on is I don't have a pointer here, but basically the OCPP part and the 15118 part. And we need to talk about grid codes. We have touched upon them, but not very much in detail. I want to go a little bit more in detail. I'm not an electro-technician, I'm a computer scientist, but I have tried to dive into the topic as much as I can. So OCPP 2.1 is going to be used for vehicle-to-grid applications. This protocol is based on OCPP 2.0.1, the current version, and it's going to be enhanced with functionality for V2X. And the first draft is going to be, internal draft, is going to be available in May, and they're trying to have the second draft end of this year. And the most important grid code settings we need to talk about I picked these 4. Limit the active power, that's basically V1G or smart charging, so you want to reduce the power demand response when necessary to not overburden the grid. Frequency watt curve, also called a droop curve. That means that depending on the frequency deviation, over frequency or under frequency, you need to adopt the power that the car is either charging or discharging to the grid. So that's called a droop curve. Then we have so-called ride-through curves or trip curves. That means how how long does the inverter, whether it sits in a car or in a charger, need to withstand certain deviations from a nominal voltage or a nominal frequency. And I have a few graphics to show you how this could look like. And volt var, var stands for a volt, volt ampere reactive. That's the reactive, basically, power. So just to give you an example, what a droop curve looks like. You have here on the upper side, not a droop curve, but the volt var curve, where you see, basically, let's go to this side. You have Q is a measurement for the reactive power. And I'm going to get into what reactive power is with an example in a little bit. And if the voltage deviates too much to the left, which is then overexcited, or too much to the right, which is underexcited, then the car needs to either inject reactive power or absorb reactive power. So there are certain settings, there are certain base points that define a curve to which the inverter needs to then react to make the grid operator happy. And similarly, we have a power frequency curve, this droop function that I mentioned, where you have a certain dead band within which nothing happens. So let's say this is 50 hertz, a little bit below 50 hertz, a little bit above 50 hertz, it's fine. But as soon as we go below, I don't know, let's say 49.5 hertz, then the car needs to start charging, or it's in positive value, but here it means discharging, so providing power to the grid. Or when the frequency is a bit high, then that means there's too little demand but too much production in the grid, then the car needs to start charging to keep the frequency at a perfect equilibrium of 50 hertz. So that's the basic idea. And here, just to give an example, I don't want to confuse you or be too technical, but to give you a practical example, this is an extraction from the grid code in Britain, the G99, where it says, for example, if this UV means under voltage, so if the voltage is 20% under the nominal voltage, let's say 20% below 230 volts, then the car or the inverter needs to withstand this under voltage for 2.5 seconds before it's allowed to shut down the system. And same with over voltage here, if it's above 40% the nominal voltage, then it needs to withstand that for 1 second. So this is how you read this, basically. So these are very important settings from a grid operator view that are often completely ignored when we talk about vehicle-to-grid. Mostly because we're talking about DC V2G, because there we have a lot of experience with solar inverters. You can store these grid code settings in a charging station, which is not walking around, it's stationary. So it's a bit easier to get that working. Now, I looked the last 2 days into the latest draft of this extension for OCPP 2.1. And what I'm trying to show here is that you see that they already think about these, they call it DER control types. So this is basically the new message, set DER control requests, which a charging station sends to the backend sends to the charging station. The idea here is that these 4 important grid code settings are reflected in this data structure. So don't, think too much about the exact details here, but what you see here is high frequency trip, that's the right through curve, high voltage trip, low frequency trip, low voltage trip. And then we have data structures that allow you to communicate the exact curve that needs to be sent to the inverter in order to abide by the grid code settings from the grid operator, both for over and under voltage and for over and under frequency, so that we can make sure that the grid is not going to be destabilized when we feed energy back into the grid. And for those who have no clue what active and reactive power is, that's often explained with a simple example that everyone can relate to: a glass of beer. So the idea here is that when you have a nice glass of beer, the foam is not really, killing your thirst, but you kind of need it as well. A beer without foam is, who drinks that? But the real power, the active power, is the actual beer. The foam is the reactive power. And in the energy grid, the reactive power is basically the inertia of the spinning generators. So we need that to keep the grid alive, but it's not really powering the devices or powering us as a human with the beer. Now, I've talked about OCPP 2.1. So we have a path towards getting grid codes properly into the charging station through a communication protocol that is widely used. Now, what do we do with ISO 15118? We all heard Dash 20 was published last year in April. It's finally, bringing V2G to the market. Yay! So how? There are a lot of services defined in ISO 15118-20. One of them is the AC BPT service. AC, and BPT stands for bidirectional power transfer. And each and every one of those services has a certain service parameter list. Don't obsess about the details, I just want to give you a high-level introduction. And here you can also see certain parameters such as what's the generator mode, is it grid following or is it grid forming? Grid following means it is just depending on the grid frequency. Grid forming means it can also provide frequency. Think about an islanding mode where your house is decoupled from the grid because we are in a blackout scenario. And looking further into the data, or into the message itself, during AC charging, there is a message in 15118-20 that is called AC charge loop, because we are looping a request and response while we are doing the energy transfer. And this AC charge loop response, so the response from the charger to the vehicle, has certain parameters that are important for us. And those parameters are the target frequency and the target active power and the target reactive power. So meaning what is the active and what is the reactive power needed from the grid perspective, and what is the target frequency that we need to achieve. This is the minimum set of requirements that the charger or the car manufacturers could agree upon when we define Dash 20. And that's great. It works for DC V2G because the inverter sits in the charging station can make sure that the car is getting the right signals to charge, discharge, and to feed in or to absorb reactive power. Now, the thing is, grid codes reflect the settings for the inverter, right? And in AC charging, the inverter sits in the vehicle. So how do we get those grid settings into the vehicle? It hasn't been defined yet in Dash 20. And from my point of view, there are two ways. Either you store all relevant grid code parameters into the vehicle, and I believe that is what Renault, for example, is doing currently with their cars, as far as I have been told. But that is something that freaks out many car manufacturers. It's too much data, it's too much memory we need to hold out for, and it's expensive and maybe not the best idea. Alternatively, we need to amend ISO 15118-20 for grid codes. So that's what I'm working on right now, with a team of like-minded people who have way better knowledge about grid codes than I do. And in mid-May, we are having the next standardization meeting for 15118 in New Jersey, and we were going to propose how to amend Dash 20 to get the grid codes into the protocol. And amending Dash 20, as far as I was told, it doesn't take years. It can be a matter of months. So I hope that maybe within this year we have a solution to finally, let's say, bridge or let's say answer the question properly, AC or DC V2G. So my answer, if you want to ask me preemptively, both. And we definitely need AC to leverage the potential as the CEO from Lade, for example, told you. All right. Now, maybe a short word about what we do at Switch. Maybe going back to the story, why did I build Switch? After I did my PhD, I worked as a consultant. First, I worked for a startup and learned a lot about the e-mobility industry for 1.5 years. I was employee number 1. That startup went bust. That was 2016. It was too early for them to make a business model out of it. And then I decided I'm going to teach the industry everything about 15.11.8. Everyone wants to know, they need to know. And I did a lot of training, corporate training. I wrote an ebook that became standard literature, did online courses until I sat in early 2020. I sat in Bali, was sipping my coconut, and I thought, this can't be it. Like, despite my effort of 5 years of training, nothing is happening in this industry. There is not a single car that brings 15.11.8 or plug and charge to market. Porsche Taycan was the first one that brought plug and charge to market. It was a year later. So I decided to found a company that brings the solutions to market. And that company is called Switch. So what we do, I think it's very important to have a holistic, vertically integrated approach of providing an embedded operating system for EV charger manufacturers. Because let's face it, charger manufacturers are really good in designing charging stations, in building them, in making them maybe visually attractive, but they are not really good when it comes to software development. Especially when it comes to keeping up with all the standards that are ever evolving, ISO 15118, OCPP. So think of it like an Android, but for EV charging stations. So that's what we do. That's one of our products. The counterpart is then our Switch platform, which is a back-end charging station management system, all built around OCPP 201. And OCPP 201 is also running on Old Joseph. And with our partner Nuvei, we heard about Nuvei in the talk yesterday from Dreeve. We have an exclusive an agreement with them whereby we integrate with their cloud-to-cloud platform so we can leverage their V2G expertise to get all the relevant smart charging profiles and V2G profiles down to the chargers that we manage. Just a short word on Joseph. What does it contain? Basically, the idea is to have an EV to charger communication stack built out of 15.11.8 and DIN spec to enable plug and charge also, and the charger to backend communication stack, which is OCPP 2.1, OCPP 2.0.1, and we have built our own grid code module to handle all kinds of grid codes. That's basically it. If you would like to learn more about our products, what we do, please feel free to catch up with me afterwards or connect with me on LinkedIn. Thank you.
So, Marc, thank you for this proper lecture. And that was pretty smart from you to hand out some candy to trigger this interaction with regard to the protocols. I have a question at first, and then the audience is very welcome. Regarding the protocol OCPP 2.1, do we need this protocol now, or can we also start with the common version of 1.6?
So we need it now.
We need it now. Okay.
Yeah.
Brief answer.
There have been so many, people try to put all kinds of things into the OCPP 1.6 protocol, including also plug and charge functionality and advanced security and so on. And the OCA made a very clear statement that the vehicle-to-grid functionality will not be supported with 1.6. This will only be supported with a 2.1. So if you have expertise in this domain, and if you're not yet a member of the OCA association, I urge you, please become a member, or if you are, please engage in a vehicle-to-grid V2X task force to bring in your expertise so we can get there faster and publish the newest version as soon as possible.
Okay, thank you. What is OCA, by the way?
Oh, sorry. The OCA is the Open Charge Alliance. This is the official body that is in charge of managing the Open Charge Point protocol.
Okay, thank you. So there are questions.
Thank you, Marc. I have a short question on how do you look at the implementation of ISO 15118 when it comes to bidirectional charging. To my knowledge, but correct me if I'm wrong, different modes of control. So scheduled, where basically the car makes the plan based on incentives versus dynamic. What in your experience worked better, and what do you see will be a more dominant implementation?
Very good question. So yeah, in 5.11-20, as Jürgen just said, we have a new mode of operation. It's called a dynamic mode. That basically means that the vehicle becomes a slave to the charging station. So it's a faster response, especially if you want to put your cars into grid services or leverage them for grid services. So the scheduled mode is where the car can, it gets incentives, maybe price-wise incentives, and it can then still decide if it wants to charge that way or a different way. Vehicle-to-grid functionality, I believe, will only work really with dynamic mode. And that is a common understanding. There's also an implementation guide, I think, from the char-in for DC bidirectional power flow for dynamic mode only. So they don't bother with scheduled mode at the moment.
Is phase individuality plan of the new the new version of OCPP or ISO 15118, whatever?
So the first is what part?
The phase individuality. So
yeah.
Because you difference between one-phase charging or three-phase charging, but not L1, L2, L3.
No, if you can go back maybe to the slides for a second.
Or is it already?
It is already. Can I have the slides for a moment? So in the charge loop request, for example, there we have a phase distinction between L1. Maybe let's go further down. Yeah. Sorry, lots of animations, but didn't want to throw all the protocols at you at once. One more. One more. Yep, here we are. Oh, you don't see it, I see it. Maybe can we get it on the big screen? Oh, perfect. So here you see EVSE target active power and active power L2, L3, and the reactive powers. That is the phase-specific values.
We have a few online comments. Is that okay if I quote them?
Pardon?
We have a few online comments.
Yeah, I would say 2 questions more, and then we have to
Okay.
hand over to the next presentation.
Then we have first one comment from Marian to be noticed. I don't know how to pronounce this. Giraffe, the roaming platform.
Giraffe.
Also proposes OCPI to connect CPO and MSP to its roaming hub.
Sorry, I was distracted 1 second. Could you repeat?
Giraffe, I don't know. This is a roaming platform. Also proposes OCPI to connect CPO and MSP to its roaming hub.
Is there a question?
No, this is just a comment.
Okay.
And then we have a question from Emil. What if we have Energy Manager connected to EVSE and want to control through EMS over backend? What protocol should we use in the system? What's your view?
Good point. I only know of EE-bus that is currently widely used, I think maybe specifically in Germany, when it comes to an energy management system in a building. And there we need to then integrate between EE-bus and the node that is talking OCPP. That's the most sensible approach I've seen so far.
Okay, and then we have 2 questions about grid codes. Can cars which are built with grid codes inside them be compatible with the coming ISO 1511820 that includes grid codes?
That's exactly what we need to discuss in our upcoming standardization meeting. So I see exactly 2 ways. Either we shovel the grid code parameters into the car and extend the existing messages that we need to extend, or we just send an identifier of the grid code. I gave an example here, the British grid code G99, kind of like an enumeration value. We just send to the car so the car knows which grid code it needs to abide by. But then the manufacturer of the car needs to know where this car will be sold to, in which geography, and make sure that the relevant grid codes are then implemented. And with all the non-harmonization currently between grid operators, that is still quite a challenging endeavor, I think.
Okay.
Good. Thank you. Thank you, Marc, for your presentation. And